All right, so where are we at again? We are on the front of the purple packet. You have already labeled the diagram. You have defined your variables. So we are ready to solve the unit problem. Our goal again is to write an equation that says S equals the height of the object, the distance from the light, and the height of the light all affect the shadow length. And so we need an equation that uses all of those. So are we going to multiply, divide, add? We don't know what that math is yet, but with all of the work that we have done so far, would you agree that we have some overlapping triangles happening here? So now with our pencils, let's draw those in. So we have this person here is forming a right triangle with the ground and the shadow. I'm going to draw these triangles in without my slate. So again, this person is forming a right triangle. So we have little triangle, and now with the large triangle, we have the top of the light extending down. So now we have two triangles. So there's not a lot of workspace on here. This is my first time kind of using this packet. I wish I would have drawn the diagram a little bit smaller. But guys and gals, you can write in all of this space here, and you just write really small. Okay? We're going to have quite a bit of stuff that we're going to add in any of this area. So again, you can write stuff up here. You can write stuff a little bit below the picture, and you have the most room over in this area here. Okay? So maybe what we should do right here is draw our triangles. So little triangle 1, okay? Little triangle 1, would you agree, has length of the bottom is an S. The height of the person was that variable H. Okay? So then big triangle 2, big triangle has this side dimension here of L. And the whole bottom going across here is S plus D. And this is the large triangle. We're going to call it triangle 2. Now we have a little bit of an issue here, guys and gals. Triangle 1 and triangle 2 both are using S. You need to be copying this down on notebook paper if you don't have your purple packet. I sure hope that was what you did with your notes earlier. So, I'm going to squeeze in the proportion over here, the first one that we have. Here's the deal. S over, would you agree, S over S plus D is equal to H over L. Okay? But here's the deal. If I set cross products equal to each other, I would have S times L equals H times S plus, I'd have H times S plus D. Now, if we had some supreme algebra skills, some of the skills that you're going to get in Math 2 next year, we could rearrange this and solve for S. But let me backtrack one little bit. Why was I able to write this proportion? Well, in this picture, let's go ahead and add a couple things, guys and gals. This person is standing at a right angle to the ground. The light is at a right angle to the ground. And this angle here is being used in my little green triangle, triangle 1, and my big red triangle, triangle 2. Question?
Could we rearrange the equation as H over S equals L over S plus D?
Correct, but your cross products will still look like this. Okay? There's about 4 ways that we can write this initial proportion. So what we need to do is we need to get a third triangle in this picture. So this is going to be a little bit above what we did earlier. Okay, when we were solving, we didn't have to, our goal wasn't to write an equation S equals. When you guys got values, there's 4 variables here. I told you 3 of the 4. You were able to solve just fine. But the idea of solving this unit problem, we need to have an equation that just flat out says S equals. So again, to get that, we need to add a triangle in this picture. We need to add another line segment somewhere that could create a third triangle, and it cannot be using the S, because that's the dilemma. Do you guys and gals have any suggestions of where I could add in another line segment to create a third triangle? Haley. Right here to where? Down here?
Yeah.
Okay. So if I did that, I would get a right angle here, which would be golden. However, this angle here, I don't have any reason to prove that it's the same as this angle here. So that one won't quite work. Rowan, do you have a suggestion?
From the top of H to the middle of L.
So you want me to draw a line straight across? Okay. And the triangle then you're referencing is, where's my black? So the triangle you're referencing is then up here, correct? Okay. Do I have enough information for these to be similar? So I have that, I would draw this in, so it is also a right angle, okay, and it would be parallel. This line here would be, let me point to it with my mouse here so people in the video can see. This line here would be parallel to this line down here. Now this line coming across, this would be acting like a transversal. And would you agree then my angle, my original angle here, from angle 1 and angle, or triangle 1 and triangle 2, would be the same here because they'd be in the same corner on a transversal cutting through these 2 angles, this yellow and blue, they're corresponding. So now, triangle 3, you need to draw this in somewhere. And I know we're getting cramped on space, but we're not quite done. Triangle 3, that's my new triangle, and it does help us. What would its dimensions be?
D. L divided by 2.
I heard from the back of the room a D. Where should I put the D?
That's bottom.
Okay, I agree. So this length, this person's feet to the base of the light is going to be the same distance from their head to the light. So that distance of D is correct. Now, a moment ago you said L divided by 2. I heard that. However, this person or this object's not always going to look like it's half of L. How could I write that, Haley? So this chunk, what I want to do with it, I want to actually take it away. And I know that that chunk is what? H. I want to take this H away. So what's this remaining up here?
H.
No, I want to take H away. The whole thing is L. Take H away.
H minus L.
Close. L minus H. The height of the light minus the height of the object would be this remaining chunk up here. So now, ladies and gentlemen, we have enough information to set up a proportion that only has one S in it. Let's set up a proportion with triangle 1 and triangle 3. So now, triangle 1 is S over what? S corresponds with?
Over D.
D. Hopefully you're following here. We have S over D equals?
L minus H equals H.
What has to go on top?
H.
h because it's from triangle 1 and s came from triangle 1. So we have h over L minus h. Question? Okay. So now I have this proportion s over d equals h over L minus h. So that is fantastic because I've only used s once. Now we're going to set cross products equal to each other. Questions? Everyone okay with why we wrote this proportion? This proportion came from triangle 1 and triangle 3. All right, so here we go. S times L minus H equals H times D. Now, we just got done doing a bunch of problems like this that was using numbers here. So we might distribute and then divide to solve. However, we just won the equation that says S equals. Would you agree that this right now says S times L minus H? We want to get S by itself. What's the opposite of times? So, do not freak out. I'm never going to ask you to do this on the test or anything, but we're going to divide by this everything in parentheses. We're going to divide by L minus H. We're going to move that chunk over to the other side. Okay? With that, my L minus H cancels on this side, leaving S by itself like I wanted. Drum roll, here's your equation. S equals H times D divided by L minus H. So, the length of the shadow is equal to the height of the object times the distance from the light divided by the height of the light minus the height of the object. That is your unit solution right there. Okay? So several weeks of work going through geometry terms so we could get to these corresponding angles so that we could create similar triangles, set up a proportion, and solve. Okay?